It was actually a challenge for me when I was invited to come here and talk leading network modernization. I agree with every comments I heard throughout the day. This is not a new concept. It has been happening for years now. It has got many real inflection points in the industry. We've, from AMD or Intel before it or other ecosystem players, we enjoyed the upbringing of serveralization into the network space as one inflection point. We see 5G as the culmination of this. And, oops, too quick. And this is simply because of 5G's ability to integrate data with infrastructure. I think Krista's just hinted to it with the different slicing and the needs to put glues between different pillars. Really, the data is getting to be the most important commodity that we all have to deal with. Network, as a major component of the infrastructure in general, is trying to keep up with the changes and the modifications, really the uplift of the data, in light also of the constraints. You have to be geared now toward flexibility, toward distribution, toward dynamic absorption of new constraints. While all of this is happening, you're also facing new usage cases that are going to be enabled with 5G. So combining all of these together, and I think you've seen many images, many views of this slide. But in general, if you have any device sitting at the very far edge and you have your data centers all the way at the very right end, in between the edge and the back end and the core network, all of these components have their own constraints, their own conditions. SLAs will differ from one to the other. We heard Joanne earlier talking about the proprietary challenge and the headache, the 80% spending that she has to go through with integration. It's going to get further compounded. So far, we haven't really exploded the wealth of 5G, because at the end, 5G is here to provide better quality of service, better new experiences to the end customers, which will dictate new business models, new products in between. With that in mind, the way we're looking at it as a software and hardware ecosystem, and from a semiconductor provider like AMD or others who work in that space, it's extremely important to understand that there are different pillars of different conditions, latencies, SLAs, quality of service, also ecosystem and players. And compounding all of these together is really the fusion of what makes sense. I'm going to kind of create the link to earlier in the day, Francesco was talking about the challenge they are having in Telefonica with estimating the capacity and understanding, because it's really the spending they have to go through. If you look at some of the streaming companies, and I had the pleasure of working with the biggest streaming company in North America in my previous life, it is actually a lot of science of artificial intelligence to build the understanding of how to understand the consumer behavior to predict the infrastructure upload. That's why when you're watching your Netflix, anyway, when you're watching your streaming over the holidays, you really don't get much disruption, because there has been a prior investment of understanding what is the peak, at what times, at what contents. All of this is extremely important. My point here is, this has not been done by only innovation, the networking. It's a lot of artificial intelligence that got into understanding the user behavior, and based on it, it's the capacity understanding and estimation and the capacity buildup. So from us at AMD, we're very excited about the opportunity and also the challenge that comes with the 5G and really the serverization of the network in general. Our ability to provide the right products in these different sectors, as well as any other semiconductor from our competition and others, whether it's a CPU or a GPU or a FPGA or ASIC, it really has to understand these different degrees of complexity. Again, coming to the point of integration and understanding, it doesn't help much if my GPU kicks ass, but it cannot be integrated in the right containerized format that will run in a serverless fashion to minimize the uplift needed for putting it in a cloud-like infrastructure. These are the kind of parameters that we'll have to start grasping and understanding when we start looking at needed innovation to support your uptake into this new era. Having said that, we're very excited, of course, about supporting you and the bodies that work in that space. And it's not foreign to us that the opportunity is enormous. The TAM of silicon only is about 24 billion in a couple of years. The NFV side of it is growing like crazy. There is a value for virtualization, which is really, it puts it on the burden of the server makers. And there are a handful in the world, and we enjoy being one of them. Funny enough, we were joking earlier, our quarterly call was just a couple of hours ago, and it's great that the market is rewarding us, but it also puts the burden of responsibility and the expectation as well. And we're here to support this new disruption, this new innovation. It's not foreign to us that the CAGR of NFV is always quadruple the CAGR of the physical appliances, even though AMD has products in both, but we understand how the market looks like. I think it was Deloro's analysis in the morning where I think the reference that you made was some of the traffic that goes on the internet is moving back to some of the cloud service providers' data centers. And actually, this is extremely important for understanding what is needed for the cloudification of the infrastructure, and networking is a component of it. The software-defined network, and again, it was a great slide that you had in the morning, where you showed, I don't remember if you made the reference to that major cloud service provider, so I'm not going to make the reference, just in case. But they do have their SDN as components, and they actually deploy it on their infrastructure as per the expectation of the workload that is going to come in the future. These are the kind of integration that we see happening in artificial intelligence, in networking, in data. And at the end, these are the new tools that we have at our disposal to drive the new experiences for our customers in the future. So we're very excited about our position sitting in the cusp between monetization and modernization. We're here really to support the industry, you being leading it, and the cloud players and the telcos and the NEPs and the others. And being able to provide that value would really stem from understanding how to provide the right services. It's an IDC report. It's simply, which I liked a lot, the success of cloud providers or any service provider in the future would be the ability to accrue value of services on top of their infrastructure. So as important it is to understand that, it's extremely important to understand what comes after it. I'll go back. I think someone was trying to take a quick shot. But with understanding these services, I'm going to actually move very quickly to one aspect that is almost percolating in all aspects of infrastructure. Networking is being one of them. We're doing similar thing with storage, so I'm not going to bore you with that. We're doing similar thing with optimizing compute, so we can take this to a side. But in general, the integration of artificial intelligence into many aspects of the infrastructure is becoming mundane to what happens next. We can take examples of what's happening in the financial services, the FSI space, and we'll talk more in a slide later on. But really compounding artificial intelligence with the infrastructure is driven also by the maturity of artificial intelligence. The days of trying neural networks for months until it converges to the right solution are over. In reality, you do training much rapid now, and you do training at much less frequency than you do deployment of inference. This is even further enhanced by the maturity of artificial intelligence in general. Machine learning, support vector machines, and other components have also matured and have been well integrated with these models. And now we have few disciplines, I'm sure in terms of security and others, denial of service. All of these are becoming parts of real existing products, and we believe it will be a differentiator in the future. So I think I kind of gave you few many anecdotes. Inference is going to be key. And inference, even though it's going to quadruple, it's going to be massive compared to the training. Point here is, when you start thinking of innovation and building services top of 5G, you cannot really isolate the application, the artificial intelligence component of the application, deployment of the application, the infrastructure, and its connectivity to edges and to customer experience. This is really the whole scope, the way we see it, and that's how we build our silicon and think of it. Whether this silicon, by the way, is for CPUs for servers or clients or dedicated chips that we build, like what we do with Xbox, or GPUs, which is second in the market today and very soon is going to be leading, hopefully. But understanding all of these different usage cases that 5G is enabling, together with the constraints, and mapping them to the right usage cases is extremely important for building the right recipe for the success of experience for the customers. I will spend a few minutes here talking about few usage cases. It's all around the mix of networking, infrastructure, and artificial intelligence. Video surveillance in general, whether it's for security or for smart retailing or for building traffic capacity or changing traffic capacity, multi-usage cases, and it's all driven, as I said earlier, mature AI models, artificial intelligence models, built on top of a robust network that is capable of responding to spikes. It's extremely important. And there are, of course, different ways of responding to that spikes, including bus over to major cloud service providers. And last but not least, the ability to isolate real tangible alarms or events to take action against it and measure the efficiency of your actions in terms of services you provided at the end. I mentioned algorithmic trading. The financial services has been leading the chart because simply they overspent in the maturity of the artificial intelligence space when it was really costing a premium to do that. And nowadays, it's not the case. Data is abundance. Ability to cleanse the data is far better than before. Training models to come up with reliable models is far more easier than before. So algorithmic trading is always referred to. I'm sure a few of you have dealt with the fire rapid trading and the conditions that it would impose on latency and the capacity. While the need to increase it, you cannot let go of the fidelity of the network. That's why there are even conditions. No surprise that the traders are closer in proximity to the exchange markets in New York City, because the longer the fiber optics, the longer the latency, and this actually doesn't meet the FCC conditions. So that's the understanding that we're going to be seeing percolating to almost all our aspects. We're talking about user experience, my kids playing with their Snapchat talks and sessions with their friends. This will be the expectations. So understanding how we can build it is key for our success together in the future. Quickly, media analytics. I refer to Netflix. Almost all content providers in North America are going that path now. They are building their own streaming services that are strongly doped with artificial intelligence and deep learning modules, while also understanding the network infrastructure and analysis. It's really that fusion is what's taking us to the next level. Smart cities, I think you heard about a couple of examples, medical imaging. Last but not least, in all of that, understanding the conditions and building on security is what is going to drive the delivery of these services. So we at AMD are very excited about this opportunity, being a part of this new inflection in today's industry. Our new products are capable of achieving, you heard early in the morning. By the way, there was a comment in the morning about the silicon manufacturing process node. It was 16 nanometer, if I believe correctly, that was the reference to the smallest node. So we manufacture our CPU and our GPU on 7 nanometer. It is the most advanced process node technology in the world. TSMC, yes. It's TSMC 7 nanometers. And there are a few other foundries that are gearing to new process nodes that we're also understanding the suitability of their technology for our products. So for the coming 2 years, we promised the industry, and we're going to be doing a formal launch in a couple of months, our new server chips, they are really not I/O bound anymore. So the ability to drive, I think today in the biggest cores from our competition, core number, it's about 28 core. Ours is going to 64. They have PCIe Gen 3, we have PCIe Gen 4. So out of the gate, it's double the bandwidth on the PCIe Gen, in addition to the multitude of parallelism as well, compounded by 128 memory channels and an ability to drive all of this. We're actually the most capable memory, about 4 terabyte per CPU, that you can get as of today. So the value of all of this, by the way, we didn't do it just to push the limits of the industry, because there will be cases where you have to do your training and your inference, while also the same silicon would have to perform mission-critical functions for your networking and your storage. It's our same silicon that would run to its fullest, would run an Oracle database to ensure mission-critical infrastructure information is maintained on your network or other database vendors. Similarly with the routing and other components. So very quickly, our 7600, it's kind of peaking toward the fattest silicon, and it will be capable of addressing the biggest and heftiest workload today. The 3000 family is a smaller, leaner, it's the same architecture, but smaller and leaner capabilities of silicon. So it fits more where you have to scale massive number while the compute complexity is not as big. Objective of all of this, I'm talking about CPUs, our GPUs is no different. Objective of all of this is to provide you with the tools for you to be able to really start the complete innovation on top of it to take you to the new realm of networking. We're very excited about this times, and that's the fastest the winner will get almost all. I don't want to say winner will get all, but the fastest to secure these new usage cases would be capable of gaining the market share lead for quite some time. And we're eager and happy to enable the whole ecosystem. So thank you so much. Sure.
So at least the last 10 years, Advanced Micro
For at least the last 10 years, Advanced Micro has been noted as a microprocessor company, servers, PCs, notebooks, now GPUs. Is that the extent of your product line? And the more important question is, who are your target customers? Are they the big cloud companies? Are they the ODMs? Are they the white box companies? Who are they?
Yeah, I'm going to start with the latter. It's all of the above. And actually, we are AMD, and I get the pleasure of working with AMD and Intel in my career, so I can talk from my own perspective, and I can contrast the picture. AMD is an extremely customer-friendly environment. And there is a reason why when AMD went under for years, they came up again, they came back, and customers welcomed their presence. So they really support these different market segments with almost the same level of enthusiasm. So at AMD, we're eager to support the whole ecosystem. You mentioned cloud service providers, telcos, and their ecosystem, their NAPs.
The white box, bare metal.
The white box, the bare metal.
Are all one category.
Yes, absolutely. And yeah, absolutely. And I think we just came back from Taiwan.
The impression I got was Intel.
Is what? Only Intel? No, I think it was driven by the products we had in the portfolio and where to compete. But where we are now, we really know we have the Rolls-Royce of the industry for quite some time. And all of this is, I'm going to come back to the GPU comment. So we're very bullish, we're very eager. I think you heard a few folks of you, I spoke to them. We're very eager at AMD to share the goodness of what we have. We believe we'll be leading that market for at least 2 years to come, if not more. So we're very bullish about it. But coming back to your first half of the question, which is GPU or CPU, it's really like my older daughter or my younger daughter more, right?
GPU, I think of NVIDIA. When I think of microprocessor, I think of Intel.
Sure, and that's fair. And I think it has been the case for Intel for CPU until we're changing, tides is changing as the market has been acknowledging. And with the new product we're launching, Chrome server, and the line is going to be available for GA in June. It's sampling with key customers nowadays. But we'll definitely be coming back to gain that market. Over the last couple of years, the amount of market share we've been gaining has been exceeding the expectation. That's why the market also has been kind enough rewarding the stock accordingly. And in terms of GPU, it's no different. So we secured the realm with what we needed to do with the CPU. And our GPU products are also manufactured 7 nanometer. The Vega 20 and the MI family are going to be productized in the second half of this year as well, toward Q3. And they will be competing head-to-head at a much lower cost and much lower power figure compared to what our competition, being NVIDIA or others. I mean, the space of artificial intelligence is not only GPUs now. You see an influx of ASIC providers, which actually we like it because it's tightening. It's going to make the strongest survive. So we like that versus a duopoly where the challenge is quite different. So we're very excited about what comes our way in the GPU side as well. Thank you, Alan.
Yes, thanks, Walid.
Sure, Shah.
You mentioned AI is becoming faster, AI, machine learning, deep learning, whatever you want to call it. Can you quantify that speed?
Sure. So in general, deep learning, I'm going to start with deep learning and I'm going to go back to machine learning. But in general, AI as a bigger umbrella, it's no magic. It really stemmed, I'm a signal processing guy. Yeah, I'm a signal processing guy by training. I moved from signal processing to computer science, to artificial intelligence, to cloud. This really has been my career journey. And I've been following the industry. So in reality, you see support vector machines. It's an outcome of principal component analysis and many other key technologies that its maturity drove into the maturity of machine learning and the robustness of the database theory and taking it into the big data with the availability of non-structured database and others. All of this enabled the big data and the analytics evolution. Deep and machine learning and neural networks were quite different because it's really a massive filter. It's a hyperdimension filter that gets trained based on the availability of the good data to train it. So it has always been hard to build the right neural network until the compute power became available with GPUs. And as such, it's like old wine. The longer it stays, the better it gets.
Right.
Now we are at that phase.
I agree with you, and which leads to my second question, which is, unless you're Google and you're operating in Africa, you're not going to get data from service provider because they are shutting down everything now.
That's
right?
exactly right.
So where do you get the data if you are AI space, machine learning space, deep learning space, and you want to train you? Because IBM and Microsoft did a fantastic job of selling like apples. They're selling AI like is Apple. You can't buy. You don't have to train the data. You have to spend 3 to 6 months data to train the algorithm, right? As you said, that is a statistical algorithm, right?
Correct.
So where do we get the data in order to, unless the service provider doing it on their own, how do you get the data?
Yeah, service providers actually are sitting on a wealth of data that, and you see a few key leading ones in North America. And as a matter of fact, in my previous role, I worked with a couple of telcos in Russia who were also leading the chart on building training models. I think, I'm going to step back. The issue with telcos is, in general, is the fidelity of the data, the sovereignty of the data, and the ability to utilize data for other purpose than whatever it has been accumulated for. So as a matter of fact, telcos do not have a lack of data. They have an abundance of it. But actually massaging that's why I told you in about 7 years ago or so, it was much easier to work that model with a telco, with a player in Russia where the constraints were much looser than the constraints in North America, for example. But this is evolving as well. And rules of engagement, the sovereignty of the data is also coming up. So understanding that and partnering with the right networking players, and they also have a lot of data they have been using it for building their new gear of networks as well. They have been capturing it differently, though, than what the telcos do. But these new service models built on this wealth of data, post the regulation and the cleansing, legal and otherwise, is really where the future will take them.
Great. Thank you, Walid.
Thank you so much.